Hi, this is NF2 Infra on the 4th of October. Right. I have one logistical question that Tal asked me to ask the people. So there is a topic next week on the agenda with respect to infra, NF2 Infra, and Tal asked me, I don't know whether people, so because I have a few sessions already, he asked me whether there would be a volunteer to present some of this. So maybe we should discuss it at the end of the session or something today. But if there would be a volunteer, that would be appreciated, because we would like to have as many people as possible visible. But it's early days for this topic, so if not, so let me know, and then it would be great if someone could do it. Yeah. So maybe I'll come back to it maybe at the end. So yesterday we had actually a meeting with Subhash and myself, basically. I don't know how you want to, people are looking at this. We had a session, let's say 2 weeks ago, where I took my brainstorm slides. Do you see my slides?
Yes, we do.
Should I do a small recap, or should we jump? Or it goes quickly, basically, right? But I prefer. Is it okay if I do it like this? Then I can edit on the fly, right? So
that's fine.
Yeah. So I think what we discussed so far is that we act solely on KRM. We are focused on a single cluster for now, right? And at the moment, we are basically modeling the flow somehow on how the system should work and what components that we need for it. And okay, there is this topic which we parked for now a little bit. So this is basically, I mean, today we are typically focusing on, let's say, rather detailed requirements. Right? So in other words, we typically say metal LB, but we don't say a load balancer, right? So, and because a customer or a provider might have different implementations. So this is something, but maybe it's a little bit too much for now, that we have to, let's say, discuss at some point, I think, right? But I think first I propose that we first build the framework and then see how we can add this to it. Does that make sense?
Yes.
Yeah. So far, I think the flow or the building, or let's say the high level flows that we had discussed last time was, we start with requirements, right? And so one of the things that that is, in essence, whether it's software or configuration, or whether it's host-based, or in my view, or my current view on the situation is, it shouldn't matter what the requirement is about, right? What we will represent it in KRM somehow, right? And I see there is two sets of, let's say, requirements. If you categorize this as something which you have full control over, right? Which you really, so that's basically your application. And the second thing is your dependencies, so things that you will depend upon, right? And I have a few examples later on. For example, a namespace, if you will. I have the feeling that this should be categorized here. And that's, again, I think it depends on the provider or the service provider that operates it, whether they separate that or not. So so these things might change depending on who operates this potentially.
Wim, may I ask a question related to that?
Yes.
Yeah. So we could either put sort of the dependency information within the spec section of KRM, or we could have an external component, another component describing that. Are there any considerations from your side of how to manage that?
My proposal is to do it as an external component. And the reason is that I think it's, or at least that's my view, is that it's easier to accommodate that, because if you specify it here, then let's say as a vendor, right? We don't want to determine how you are using it, right? So if some of these things come from the vendor, I don't think it's good that we are already classifying it this way. It would be better that we do it, that we have somewhere a system that basically does that mapping potentially. And as a result, then this becomes more flexible, I think. Yeah.
That's fine for me. Nevertheless, I would like to mention two things. First of all, the aspect that sort of dependency information is typically something which is coming from the vendor. That means, at least in an abstract manner, this should be information which is provided by the vendor. If we are, of course, going to the implementation aspects, this was this discussion regarding load balancer versus metal LV, then there could be the situation that we say we need to sort of expand this information so it captures also the specific implementation details available.
Yeah, I see, let's say, two things, right? So one is this abstraction layer. Right? So ideally, but I think this is really a step too far maybe at the moment, but ideally, as a vendor, we say we need a load balancer, right? So the challenge that we have today is why are we specific today? Because we are trying to validate all of these combinations, right? And then we say, okay, this we tested somehow, right? So that's why we say, okay, it is this and this version and so on and so forth. I believe that, and the reason that we do that as a vendor, right, is because we came from this, I call it the black box approach, right, where we controlled the whole world. And now we are going into this disaggregated world where we control only a very few items, right? And so in order for our quality process to work somehow, is we basically specify all of these details. And that makes life easy, difficult for everybody, basically. Now, to loosen that, okay, so that means that depending on the environment you're in, you have to probably or potentially do additional testing, which you haven't really catered for. But I think we should, I think if we want to succeed in this space as a three-party, right? So the cloud providers, the service providers who are operating it at the vendors, we have to loosen that those requirements somehow. Otherwise, we will, there will be too much conflict, and it will never. As an operator, it would be way too hard to operate. But okay, that will take a little bit of time. So that's why but we have to build that in the system, I think, if we design it right now, such that we can go there eventually, right? Should not reflect, should, so the, wait, so on / depends upon should not be reflected in the requirements. Should be handled separately, right? Okay, so I just put notes. Yeah, sorry. Yeah, go ahead.
So would that be some sort of external metadata or something, or?
Yeah, so so I don't know yet how to make this work, Liam. I'm just I'm brainstorming between all of you, right? And please chime in if you have.
But okay.
Yeah. So just to give you a sense of what we are talking about here, let's say practical. Let's take namespace. Okay. Okay. In some environments, a namespace might be let's say, controlled by the application vendor itself, right? By the application. I call NF, it's for me an application, right? So I call everything application these days. So So the thing is that if you are, let's say, DT, and you say the namespace should be controlled by the infra team, right? I'm just making a hypothetical scenario. That means that that object, if you will in that context be owned by the infra team, right? Whereas if in another, let's say in Orange, it would be controlled by the application guys, then that object or that KRM resource would be mapped towards the application team, if you will, right? So that's what we are talking about here. And maybe namespace is I don't know whether it's a good example or a bad example, but that could be one of them, right? Like a load balancer is another one. Normally, I think it should be mapped to infra team, right? But who knows? And then, for example, RBAC rules is another one. That's typically security team, right? So, but okay, depending on who operates this, that mapping could change, right? Okay. So, okay, so and I think what we are, if I would draw the abstract part into this drawing, I think there is a step before here. So before this one, which would be, from my perspective, so if I'll screw up this picture a little bit. So if you look at abstracts, I think it's a step here, and then, yeah, I'll fix this picture a little bit better, which then gets mapped to the specific implementation. So, for example, a load balancer in let's say in DT, it's MATLAB, right? In the other case, it's Nginx or something like that, and in the cloud provider, it's a cloud-based solution, right? So that means that this implementation and it can also be, so you could even map it to the environment variation, right? Because it might be that for private cloud, it is X, and for public cloud, it is Y, and stuff like that. So it could also, we could also look at this from as an environment variable potentially as well, right? But there needs to be some mapping to an implementation somehow, right? So that could, we could also think about it at this level. So I'll remove it for now, right? Environment variations, yeah. But what this block was trying to reflect is that so abstraction is an example of the environment variation, but also, for example, specific identifiers or IP addresses or something like that. So there can be various elements that are specific to an environment that, and so as a result, we get what I call the expanded KRM. Maybe that's not the right term, but so basically this gets run through a system that actuates or expands these variables somehow, or these parameters, to a specific environment. And I'm not saying to the maybe exact specific requirement that will be actuated, let's say a pod IP, not necessarily, but maybe a subnet or something like that, right? So at that level. And then we have, so the next stage is basically, so from the moment we have those requirements, let's say, captured towards a specific cluster, because here we're talking about the cluster level, we have to, so this is basically what we want this application to accomplish, or what resources it needs for it to work. We have to validate that against the actual situation, right? And also depending on the owners, right? So I put here, yeah, so the depending on that mapping that we discussed before, there might be various, let's say, people or teams that act, and whether they do it in a fully automated way or in a semi-automated way, so that's an implementation detail from my perspective at this level that that would be agreed upon. So in case of the menu, so what happens here, for example, I need a namespace, right? Let's say someone manually executes it, then the person or the group responsible for the namespace in the manual approach will go and configure a namespace. And once they are done, they will say, hey, I'm done, right? So that could be one implementation. The other implementation, which would be fully automatic, is that he gives a requirement. There is a controller that sits here, and he is going to look at the actual state and then the real state, and he actuates it by himself, right? So it's, and then, yeah, sorry.
So it just comes to my mind that I believe that in this process perspective, we should try to differentiate the different steps a little bit more, in the sense of that in the setup phase where the infrastructure is providing and sort of its capabilities and populating this this information into some kind of repository, we need to be able to determine what kind of elements are sort of being made available for which cluster. So there needs to be some guidelines of how we structure that type of information. And therefore, I believe that we would need to have a process step before we do this requirements aspect, that we also do this sort of, let's say, setup process step where the infrastructure provider populates this repository with a certain set of information.
Yeah. Yes, I think, yeah. So yesterday, by the way, we tried to, sorry, Liam, we tried to start this mapping. So maybe, yeah, Liam, you go first, but we tried yesterday with Subhash to get, let's say, a decomposition of this part here. Okay, yeah. But Liam, you go first, yeah.
No, I was just thinking, I guess then there's something in the cluster that gathers all this information and then does some sort of resolution, I guess, to see what it actually needs to run. Is that the...
Yeah, so what we tried to do yesterday with Subhash, right, and is, if you look to, and we didn't make a distinction of why, but just to list what should happen, right? So, and we have here, let's say, a set of requirements, and we have here the actual cluster, if you will, right? So that's basically what we have here, right? So we have here on the left-hand side our requirements, and on the right-hand side, we have here clusters. My thought was that we model this as individual KRM resources, right? So if that's one thought, I'm just brainstorming right now. So which means that we could actually look at a controller logic to do that. For example, here we yesterday discussed, let's say we want OS, maybe this is already a very difficult or a very complicated one probably, but let's say take namespace, right? So if we say namespace is what we want, and the actual cluster has the namespace acted upon or not, right? That then basically we need something that can validate the desired state, which is the left, to the right, which is the actual state, right? So that's, so if we model this as a true KRM system with the individual resources, that would be, let's say, straightforward to do.
Yeah, that's fine. That's fine for me. That's fine for me. But what I wanted to highlight is that before we do the actual mapping, we need to populate those requirements or these capabilities of the infrastructure. That means,
yes,
sort of before you sort of execute this loop, there needs to be a step where we specifically say this cluster can be configured in the following way via these KRMs. And this is one step which is missing for me from a description point of view, because it's not like that we want to expose any kind of resource and say you can now manipulate that from a requirements perspective. We should be able to highlight those elements which are sort of allowing to customize the cluster state, and therefore we need to have some kind of indication of how I can determine which elements are sort of subject to that type of customization.
Yeah. So for me, so to a certain extent, Bernard, this is actually and how we model and store it. I did not make a distinction, or I did not have any thought on so far. But this, in essence, these are individual KRM resources that are linked to that application, right? So
I agree, but nevertheless, I just wanted to highlight. I also described that in the user story. You might remember that this onboarding process of the infrastructure provider needs to be described as well. Because based on that, we can then determine if, for instance, the infrastructure provider might need to sort of add additional functionality. And therefore, we need to be very clear about what kind of KRMs are related to the customization aspect of those clusters.
I see. Yeah, I see. Yeah. So I made it's at the moment it's very abstract, right? So at the moment we did not go into the detail yet. But what we tried to do yesterday and is maybe what we should discuss is to see whether we have all the elements that we need to have in the system, that we identify them. So for me, one is basically, of course, describing describing the resource. So we need to define the resources, right?
Yes.
Which is what you say. Define resources we need, right? To define resources with respect to requirements. Yes, go ahead.
So if I followed Bernard's comment, so in this first bullet, are we defining like the capacity and capabilities of individual resources per cloud provider before actually?
Yes. So the cloud provider would basically say, you can, for instance, now enable SIOB, you can sort of customize namespaces, you can do whatever. And then basically it sort of shows what kind of customization options sort of a network function potentially could make use of.
Yeah. So Alok, for me, this represents the eventual KRM, all the KRM that we need. Some of them will exist, right? Some of them does not exist potentially, right? So
I'm trying to draw like the end-to-end flow in my mind. So starting with the high-level requirements that gets converted into corresponding KRMs, right? And then it goes for the actualization to the providers, right? The cloud providers. But in between the step, like to which cloud provider these set of requirement has to go depends upon the capacity and capabilities individual providers provide, right? So, I mean, is that the thought process?
That's part of it. Now, what we decided so far to do to make this process a little bit, let's say, easier, or at least the current conversation a little bit easier, Alok, is that so normally there is a scheduler somehow before us, right? We decided for now that we will focus on someone has decided to go to this cluster, right? And we want to create a process to ensure that what we want to, so that we are able to express those requirements and validate it with the actual state. So we basically shortcutted one step, which just to ease the conversation, because otherwise it's a massively complicated discussion, I think, right?
But isn't it this what we call as a homing decision, like where exactly my NFs should be deployed on which particular cluster? And if there are certain, let's say, if I have some sort of an inventory model exposed by individual cloud providers, what they support, then that will help the homing logic, the homing controller that basically makes the decision, okay, this particular NF should be deployed on this particular cluster because that fulfills, as per the inventory, the set of capabilities.
Yes. Now so you can look at this. I think when we discussed before, we can look at this from various perspectives, right? One is you can do what you just said. I have a certain capacity and I will try to schedule the NF, right? Based on that requirement. You could also think about another philosophy to say, okay, I don't care what capacity it is. I just want to, I will increase the capacity if I need to. Right? So depending on your policy, you could go either way, right?
But extending the capacity, there is a twofold thing. I mean, if it is, you have the physical capacity on board, then you can definitely provision new resources and that can be added up to the cluster. However, if you need to like source the physical resources, then that becomes an equipment management thingy, and that's out of the service provider control, right? It is
Yes,
internal
but
to
in
the
the
cloud
cloud,
provider. Yeah.
in the cloud, it's flexible, right? Because there you have virtual machines, you just spin up a new one, right? So, but so Alec, for now, we try to stay away from that because this makes, so as you were pointing out, this makes the conversation way more complicated. And so we decided, okay, let's assume that we have, that we know the cluster, right? And we are going to basically define the requirements. We will come back to the point that you were highlighting, right? But for now, if we also do that, I think we are not going to, we'll have continuous conversation with no progress. So that's why we shortcutted that for now. And
because
we focus on.
The reason I made that comment was because very similar conversations we are having in the ORAN context as well. And as we are discussing in other forums and different channels here in Nefio about how we can align Nefio architecture with the ORAN. So if I give a example very quickly, so in the ORAN architecture, we have the northbound layer, the SMO, right? The service management and orchestration, and that provides the high level intent, same as you talk about the high level requirements, right? And then that will get provisioned and realized by services like the infrastructure cloud provider services, right? The IMS, that has to provision those resources accordingly, and that includes the cluster provisioning as well. So, I mean, the thought process here is we should have some sort of an inventory model for the cloud as well as for the upper layer like the SMO, which helps to make the decision like this is the cloud provider and that particular cluster I should select for deploying my applications because they hold certain capacity and characteristics to fulfill those requirements.
Yes, yeah. Now, to your point, right? If you are in a physical world like radio, right, where it's very hard to add capacity, you basically the capacity constraint is definitely an element that you have to take into account in your scheduler, right? Because you are not going to all of a sudden on every site add a node or whatever, right? So you will probably have a
right, and that's why I was
uh,
said like inventory model is necessary to decide like, okay, this is the capability and capacity I hold. And for that purpose, that will help the controllers making the decision, this particular cloud infrastructure I should select rather than the other.
But what we are discussing here is not tied to radio only, right? So we want to build a generic system that can be accommodated for every at the moment. And that's why I wanted to leave that a little bit out for now because it opens a lot of additional constraints that we we will go there. We will go there because for me, I always say if we have what I'm trying to do always, if we have the route foundation at the bottom level, which is what we are trying to do here, going up is easier. Going from something that is not right at the bottom to something on top, it makes it complicated. So I'm trying to, in the first step, get us the building blocks at the lowest level agreed upon, and then we move to the higher level. Because if you, my view is always if we have the lowest level right, building on top is easy. If we combine all the things, it makes it very complicated. Stephen?
It sounds like we maybe want to try to solve a little too many problems here. So my understanding in the very beginning is you are now expressing statically in the package almost, or within somewhere within package with a custom resource that will tell you that for me to run as a network function, I would need to have this set of capabilities. I mean, you have to have a cluster that has nodes that can support SRIOV. But then that's different from saying that now I'm scheduling this network functions to this cluster that has, say, 2 nodes, and then each node has 32 VFs. on the NICs, and then we exhaust it down to like less than the needs based on your dynamic capacity, because they're based on user input, right? User input will come in and say that I need this to have this kind of throughput, and then maybe network functions would be looking at how much resource they need to consume. That's very dynamic, which is a very different problem than saying that I need infra. For me to be even going to any infra at all, there has to be a cluster that has at least an SRIV support. And then at the time when you actually deploy the network functions is when you realize perhaps you don't have resources. So resource consumptions are much more dynamic than capabilities that could be actually supported by the infrastructure.
Fully agree.
Yeah.
I mean, and that's exactly I was after when I say capabilities versus the capacity thing, right? The infrastructure has to support certain capabilities, since like you gave the example, the SRIOV support, right? That has to be there from the day zero point of view, and then there comes the dynamicity, which can be added later. Yeah.
But so I just to make it clear, right? So we, if you look to our original slides, right? So the one that we presented in SIG 1, is that we had the scheduler. So this is the part that I'm saying, okay, let's try to avoid that for now, right? And let's go to the detailed implementation for now. So we are basically discussing at this level, but we have to come back here in my view, eventually. Right.
Yeah. So the scheduling part. Yeah. Eventually something needs to go there. So then there's one problem to solve, which is expressing your requirements statically without when you're network functions, when you're bundling, you're expressing this a set of things that I need a day zero, as Luke said. That I need to run at all on the infrastructure. So that there could be like a static requirements that it's being sent to the infrastructure admins by telling them that please give me a cluster. Please prepare the nodes. I mean, not even cluster yet. Please prepare your set of nodes that I could make a cluster off, where at least you can run a vendor X UPF, and then so maybe software would do it, maybe human would do it. They would install all the kernel modules and all that stuff to make sure those nodes are in place. Maybe giving SRIV policies already, so they would allocate things that you can annotate, then you can consume. So that's one stage. Then the second stage would take in the user input by telling you that I'm deploying this UPF with this capacity. And then that gets scheduled into a cluster, or you create a cluster actually dynamically even. But then let's not get too complicated. I said there is a cluster.
Yeah, correct. But it's a good point that I think Alok and you made is that we are really talking about the capabilities. That we are trying to focus first on the capabilities rather than on the detailed capacity requirements. Right? Does that make sense?
Yeah, because obviously right now Bernard is our only users on the call, so I'm guessing those are like two-stage processes, right? So
yes, I would agree.
You're asking an infra provider to give, not a provider, an infra admin to prep a set of nodes that would possibly allow us to deploy this, and then the actual deployment. And then both of these involve infrastructure. One of them is statically, I have that support on my nodes, on my Kubernetes clusters and kernel modules and CNI binaries and all those things I install. So I'm ready for you. And then at some point when you deploy, it may or may not be actually capable of doing it. So
now they go a bit hand in hand to a certain extent, right? But
yes. So you don't want to go outside of the boundaries of what you're asking the infra admins to set in the first place. So it is the set of capabilities. So one of them is capability listing. The other one is I'm now consuming resource. So one of them is static. The other one, so I actually raised that point at one of the Sigma meetings. So one of them is more like a static listing of, hey, this is what I have. And the other one is this dynamic at runtime, quote unquote. You want to consume it. and then that's I think that's the sort of two different workflows.
Now they are related, because see, I'm assuming right now that because the capacity somehow, but it's also relative to the context that you apply it, right? So towards point, what I think alloc is actually is alloc the right? Am I pronouncing it correct? It's
Perfect.
that's right,
Yeah.
right?
Alloc. I use alloc. So sorry about that.
Yeah. No. That's totally okay.
Yeah. So Alec, what I'm trying to say is, to your point, is that I think for me, inventory and capacity and stuff like that is more relevant at the scheduling level, right? I mean, it's also relevant at the lowest level, but probably relevant here. Now, as I was pointing out, depending on the environment, and that's probably where the policy fits in, if you apply this on the radio where you have constraints on capacity, right? It's a hard requirement, right? Whereas if you deploy it on the cloud, you could scale elastically potentially, or even in the core, you could basically have someone at capacity to the system to be able to accommodate the scheduling. So it depends on what I'm trying to say is there will be a policy at this level even to accommodate for some of these things.
Yeah. So we talked about this capacity versus capability, and I see like capabilities are tied with the homing decision, like which exact cluster I should select and those type of things. So that depends upon my capabilities I provide as a cloud infra provider, right? And then comes the capacity, and which is more tied with the placement decision, like on which particular node I should deploy this application because of utilization or any other aspects. So these are, I mean, that's how I connect these capacity versus capability discussion.
So what you're saying, let me capture it. Capacity versus capabilities. So what you're saying is capabilities is more. What you're saying is the cluster.
So the place, the homing, right? The homing capabilities. Like,
but homing, is it also not placement?
No, the placement is, let's say when we have cube scheduler, right? That makes the placement decisions, right? To which particular node group or a node pool that placement should happen, right?
But placement is in your case in the cluster?
Yes.
Okay. Okay, but because I even
and
see
homing is
this,
about on
which,
out of
which
how
cluster?
many, which cluster exactly. Yeah.
Because I even believe there is now we are discussing this. I even believe that this plays a role here potentially. So toward the point of the run, right? Let's say I have a run, I have the node has a certain capacity, and the chances for me changing it is close to zero, right? Or even an edge scenario, like I have a computer in a retail store and it's X, right? And can I schedule the application onto it or not? But maybe, if it's not having sufficient capacity, there's no point in deploying this anyhow, right? So because you have provision
if I pick the same example which Stefan was quoting, the SRIOV, and that becomes the capability. And if a particular cluster has the SRIOV capabilities, then and only then I'll select that cluster. And then the capacity versus the placement decision comes in later to which particular node or a node pool I should deploy my application, right?
Yes. Yeah.
So yeah.
Now so just to and maybe that's also a good conversation, is the assumption that I'm using right now, and that's why is that any cluster can eventually get all of these requirements, maybe, and that's where your selection comes into play, right? So is that you're basically saying that, I'm assuming for the time being that the requirements that we are going to get, somehow we will be able to fulfill one way or the other. Now, of course, if the capacity is not sufficient, then either you get auto scaling, and in the cloud you can get an extra VM and stuff like that that automatically gets provisioned. So even there, but in the physical world, that's probably less capable. So at the moment, the assumption is that the requirements that we are going to get, we somehow are able to fulfill. Is that assumption for the time? That doesn't mean that we don't have to put in the guardrails to prevent that from happening, right? If we cannot do it. But that's my current assumption that I'm using for the time being.
So from our
sorry, go ahead, Bernard. Sorry.
So just to clarify why this is needed from our perspective, because we do have a set of clusters which we would like to be able to sort of support, where we would like to support different type of network functions over the time, so that we do not have to sort of re-provision dedicated resources every time a new network function comes along. And since the network functions have different requirements, there needs to be a process of how we can customize the cluster to account for those different requirements.
But which means, Bernard, does it imply that somehow these clusters, you're making the assumption that those clusters can be accommodated for the requirements that you put in place?
Yes.
Yeah.
So if you're going to repurpose a cluster or reuse a cluster already in place, it's something like, and then assuming the app owner, the one who deployed the apps, the network functions, has the admission control privileged, so that they're able to do any kernel changes, for example. The cluster would have to be repurposed. So there'll be a stage where you want to go from, lack of a better way to say, Ericsson UPF to Nokia UPF, and then they have different requirements of kernel modules and other install softwares. So forget about all the other things first.
Yes.
So that to me is capability change, right?
Exactly.
Because now you go from Ericsson to Nokia. There are a list of things to get the nodes ready on an existing cluster are different. So that is expressed by capabilities.
Right. And to make it, yeah, go ahead.
And then so you're preparing the nodes, even though you're using existing cluster, you're now preparing the nodes to a point where you're switching from vendor A to vendor B. And then
or the vendor has an upgrade which requires additional capabilities or whatever.
So vendor A, version A to version 1 to version X.
Yeah.
And then when that change happens, so that's one stage. One stage would be statically, I'm telling you, for version A to version B, these are the capabilities that are changed. And then that will be enough information for backend to, for example, uninstall all the things that are not needed, and then install the things that are needed. And then the second stage would be the deployment engineer now ready to deploy. And at that point, that's a resource consumption issues. So now the cluster supposedly is capable of, in terms of capabilities, it has the features that are needed for that new version of software. And if you spin the first instance and a second instance and it's all working, and then by the time you spin another instance to scale up and so on, there's a resource issue that you wouldn't be able to spin the third one. That would be a different workflow, basically, because that would be failing, not because the nodes are lacking capabilities, but then it's just the fact that the cluster is lacking capacity of doing so.
Yeah, so there could be sort of also a capacity calculation, an initial capacity calculation, sort of before you do the onboarding. This is what we often sort of do when we're developing the CIQs, etc., to see if the capacity amount of nodes which are available for the workloads are sufficient. So that could be this additional aspect to be considered.
Okay.
You could do some of the capacity validation here if you want, right? In stage 1, but right. Is that the right term? I'm just putting notes here. is that you have two stages, right? One is capability, and the other one is capacity based, right?
Yeah.
Right. But yeah, so what we are discussing so far is mainly this.
Yes, that's what I could see from your discussions. Yeah, your brainstorming seems to be pointing in that for now.
Yes. Yeah. But I mean, we could. Would it be okay that we first flush this out? So this is, and then we take this in, or you guys have you have a different view?
Yeah, I think that will be a better approach.
Yep, fine.
Yeah. Okay. So yeah, I'll have to probably repurpose all of the text. But for me, it's a brainstorm. I prefer to do this session online with making notes than at least something is captured. But okay, yeah. So basically, if we have, let's say, those capability requirements somehow captured, then we have to validate it against the actual state, right? So what we tried to do yesterday with Subhash is define the different things that need to happen to do that validation and so on and so forth. So step number one is, of course, defining the resources, right, that we need, right? With respect to capabilities, I will change it, right? Capabilities, right? Capability requirements. So we need something that validates the actual versus the desired state, right?
Mm-hmm.
What we also discussed yesterday is we have to, that depends on how the system works. Let's say I have app 1 and app 2, and they both ask for the same namespace, or they ask for the same kernel module. So this example is always the same. If one disappears, we should not delete the resource somehow, right? So that means that we need to track various requirements.
So that's the user question now. Is that common? Is it common that we create clusters that would be deploying two different NFs or different versions of NFs? There could be an overlapping namespace or something like that.
I mean, this is probably not the right example, but let's say they both have the same kernel module.
Namespace, not so much, but
yeah,
maybe, but other things for sure, absolutely.
It
could be a particular type. It could be particular type of database, like Mongo or something like that.
Yeah.
Mm-hmm. Yeah. So we do that for our one when we dump everything other than UPFs into the same cluster. But then, so they're different NFs, quote unquote, but they're from the same vendors on the same versions with the same external requirements. So if they use Mongo for NRF, for example, and then it would basically all be using the same version of Mongo if they want to access Mongo.
Yeah, but if you want to go for a modular approach,
mm-hmm.
where we say potentially we would sort of want to be able to mix certain things, because, for instance, a monitoring solution should also be put onto the cluster and it comes from a different vendor, etc. Then we should have the possibility of bringing those elements together.
Yeah. So like Prometheus, I think namespace is probably a bad example, right? But like Cert Manager or Prometheus or ISO monitoring or so observability type of stuff, I think that's more common, I think. But of course, I think it assumes, Stephen, is that you will have potentially multiple vendors or multiple mix
on
potentially.
on the same cluster. Yeah.
But I think we should design that. Maybe it's not practical today, but we should design for people to be able to do so, right? Because see, I don't want. Just to be clear, my goal here, my dream, maybe call it like that, is that what we design here is not specific to network functions. This could be applied to any app.
Yeah. Now you can get into the weeds of this a little bit because version X, something wants version X of a system of Mongo and something else wants version Y, and there's something deprecated in the new version that the old one needs. You can get into also you need two versions of the thing. I mean, it's common, in all systems. But let's stay out of that for now.
Yes, but Liam, so my view on that is this, right? Okay, so I think that's why this bullet was still left onto the table, and it's probably not so clear what we meant, but I have the view, my theory of this was the following, right? So, okay, we will have apps which have certain version, let's say, dependencies, but it's for the same reason that I mentioned in the beginning, right? We want to control everything, right? Now, I believe at some point, the operator will decide which version they deploy based on certain criteria, right? Let's assume, same way for the abstraction, right? So if I say it's a load balancer and they selected Nginx or whatever, right?
Yeah.
Then that's a decision, and they also have a version. So that means that if you get let's say, I'm not excluding you from specifying the version, but at some point there will be, so it comes down to this process here, is you will have, let's say, an environment adoption. Now, if you see that there's a conflict, right, there's two things. The vendor, so this could trigger potentially the vendor, so the operator to trigger the vendor, hey, you need to validate against this version because that's what we deploy and we have no plan to change, right? Or the operator basically validates that new version that that vendor has and needs to accommodate that to the other applications that are deployed, right? So either, that's how I look at this a little bit.
Yeah, we have to try and get away from this tightly coupling of NFs to the versions of the underlying things, because that makes life really complex in managing these dependencies, and often it doesn't matter.
Correct, but it's just because you and I, so it's the same for us. Our QA resources, they are asked, hey, please give quality, and if quality means, okay, I've tested it with this version, then they say yes, and otherwise they say I don't know, right? And then you have all the support, so then the whole chain starts, right? So,
and then
for sure, vendor qualifies external dependencies. They can just say that we'll support all future versions, right?
Well, but the other thing that's getting really more complicated recently is the security, and that you have to verify that all your dependencies are secure. And then what does that do? You say, well, I have to nail it to a particular version, and I have tested that and to check that it's secure, but the next anything else might not be, and that's something else. Maybe we don't take it here, but it's something to consider.
Yeah, we have to put that in some.
Yeah,
but
I saw stuff, and you know the stuff.
Yeah, I agree, Liam. But at the moment, I'm capturing this here at environment variations, which is, so maybe we have to add here a note that this is accommodating for abstraction / versions, right?
Yeah, but if we can find some way of I wouldn't say avoiding it, but I would say abstracting, as you say, abstracting it is the right word. So that every time that we come along, we don't have to go through this. Would be really good, you know. This tightly coupling of versions of applications to particular versions of underlying stuff is something that we want to get rid of. We should take out that complexity if we can.
Now, I think you cannot completely avoid it, right?
Of course you can't. No, but
so I don't think it's avoidable. But the question is, do we build in some provisions of, let's say, as I was saying, you could do, in my view, two things for now. Maybe there is more, but let's say we specify the requirements as a vendor. We see there is a conflict, and either the vendor has to, so it will trigger the vendor, or it will trigger someone to take an action, whether it's the vendor, the operator, or the integrator, right? Because that's the three parties that you typically have, and then to do something about it, right?
But I think it's like you said at the very beginning. We specify we need a load balancer that can balance so many requests a second over so many things, rather than saying we need Metal LB version 2.3.5. That's the difference. Maybe.
Okay, so maybe because we are almost out of time, right? What I try to do here, and maybe that's good for everybody to maybe have a look at it. So these are all the, let's say, things that we need to accommodate for, right? So one is check desired versus actual state. One is track overlapping requirements, right? Approval, yeah, so in the approval cycle, you could also take into account, let's say what Subhash was mentioning, an admission controller, for example. We don't allow privileged access, and he was asking for it, so there could be some admission controller about it. And we need, in my view, a dependency controller that's then more for the actuation to deal with that, right? So what I would ask all of you is maybe review this list, whether you agree or disagree, or maybe add items or delete items. Because we probably have to, at some point, we have to decompose the system with those building blocks as to what needs to happen here.
Okay. Agree. There's one additional aspect which comes to my mind, that is in the deployment phase. We just imagine that everything is fine from a, let's say, a semantic perspective. Every capability is sort of available. Then you do the actual deployment. Then in this context of this deployment, additional information arises, which might be needed in order to configure the network functions. So we might have to think of a staged process where we first make sure that the capabilities are there, collect all the information resulting out of the sort of configuration aspects of those capabilities, and then feed them back into the configuration of the network functions.
Yes. Now, is that some... What is the example of that? Like a VLAN?
Could be.
Okay, because at a certain extent, the dependency controller is the one that is going to be playing a role in actuating. He's probably not doing the actuation from my perspective, but is going to say to the actuator in what order it needs to happen.
Yeah, so I just wanted to say that if we can do that at runtime, that's also fine. But if we have to do that during the configuration time, then we have to have the staged process where we feed back this information to the configuration of the network function.
Yeah, from actual info to the what is it? NF, right?
Yes.
Yeah, DBD. Okay. All right. Yeah, so this is yeah, so we are out of time actually, but yeah, so let me first come back to the original question that I asked when we started. Is there anyone feeling, let's say, okay to take the slot of the infra, or you guys think it's too early? What I propose is that I think we don't yet discuss this detail, but I would propose to basically take this high level, because here we got somehow consensus upon. So that's what I was planning to do, is maybe focus more on what we are trying to do, and then say, okay, we are discussing the building blocks and we are trying to decouple it. But the fact that most likely in R2, we are not going to, my goal of R2 is to build, to have a detailed framework and decomposition of building blocks that we need. If we achieve that for R2, then I think we have done a good job. But
the use case for R2 is to be able to do something different between OAI and FreeFlyGC, right? I guess for what we're trying to demonstrate anyway for R2.
Yes.
So obviously we have a framework to support this, but that, yeah, and obviously there's no SLIB and not anything involved there.
Yeah.
For now.
Yeah, so at the moment, I think for R2, my thing is more of a specification and let's say an architecture building block thingy, right? And then probably in R3 we will implement some of these things. That's my, let's say, thoughts. But my goal for R2 is to have a architecture defined, right, with components. So like, for example, here, hey, we need a dependency controller, and it sits here. We need maybe an admission controller. We need to do this feedback loop and stuff like that. So that we have let's say, a view on these building blocks, and then that we somehow know for R3 what we need, and we can split the work into pieces. Right? Does that make sense? Or not? Because right now in the cluster, we assume SRIV is there and we deploy, right? And nobody's checking anything.
Yeah,
and we have
for everything, basically anything.
Yeah, correct.
Yeah,
so that's what we are
we're
trying to
not
change.
checking. So the only thing we use is Mac VLAN, and then no one ever checks if Mac VLAN is really on the node.
No, we do. We do check. By the way, we do check in specialization. By the way, but what
checking the installation, really? Okay.
No, but it's statical, right? So what happens is the workload cluster has Mac VLAN So when we do the end-to-end flow, we create a workload cluster which has Mac VLAN as an option. So if that option is not there and we deploy it, we will fail. Specialization will say not possible.
Okay.
But it's not. There's no actual state, so there is not feedback. It's all static, right? So it's kind of very primitive. But that's about it, right? So it's also true for networking, by the way. So if the network is not provisioned and you ask for an interface to the network, it will fail. So specialization will fail. So there is a few checks in specialization.
Yeah, for sure. We've seen failures that SCTP is not enabled.
Yes, correct. So there's a gazillion amount of things where we don't, right? So
and the GTP 5G is not there. People, I think Vish and others still bump into those problems, so we're not checking those for sure.
Right. Yeah, for sure, 100%. Yeah, there is lots of stuff missing, but the goal here is to build or define a system that does some of that stuff better. So yeah, so if you have second thoughts on the presentation next week, please let me know. Otherwise, I'll be the one, I guess. And I think your next week is probably hard to meet, so we'll probably resume the week after, right? Is that okay?
Yeah.
Yep.
And then
please,
that's fine. If you have some thoughts and stuff like that, add your items to the agenda. So I add in the Slack team. In the agenda, you can add stuff. So I set it up that you can add items if you want, and also if you can comment or add items into the slides. And I'm going to keep this Zoom meeting for now. It seems that I don't have to reschedule, but I'll add it into the calendar. But then we keep the Zoom meeting.
And time will not change. So this is a good slot.
Is this okay or?
Yeah, for me, but then obviously not good for like East Coast people or whatever.
Yeah, East and West Coast. You yes, but
yeah.
So for me, the timing can change.
You wouldn't see John here, for example.
Yes, yeah, correct. So for me, the timing can change. I have no problem with it. But the problem is, so the thing is, then we can do 8 a.m. specific, but then also you and John are not okay, right?
Yeah. So both of us will be missing at least half an hour.
Yeah. So anything before 9 is a problem for you and John, I think, and then after 9 it becomes a problem for Europe.
Yeah, and India. Yeah.
Yeah, and India. So that's my problem a bit. Timing wise.
Yeah.
But anyhow, I think so my goal is we discuss here in a smaller team, right? So we prepare. We anyhow agreed that we are going to present it to SIG2 where we have the bigger team then. So maybe at some point when we have the building blocks and the framework somehow agreed upon between us, we will ask for a slot in SIG2, right? Either the Wednesday or the Thursday, and then we invite the other people and get feedback, right? So that's how I look at it, that we should operate here. So anything we decide so far is not really a decision, right? So it's only will be okay once we get an approval from the architect from SIG2, right?
Yeah.
So that's how we should
consensus. Yes.
Yeah, operate somehow, and that's the only way we can probably make progress here, because otherwise we have a time slot. The issue is scheduling the meetings.
Yeah. All the 9 a.m. Pacific slots are all gone for the whole
They're all gone, right? So except for Friday.
Except for Friday, which would be no one showing up anyway. So that's
all right.
Okay.
Thanks very much.
We're assuming none of the meetings will happen next week anyway, so that should be.
Yeah, no meeting next week. So I'll ask for a slot the week after. All right.
Well,
thank you.
See some of you guys
Thanks all.
next week.
Yes.
Bye.
Bye.
Bye.